Google just made $20 billion in a single quarter off something that essentially didn't even exist as a commercial product 3 years ago.
Which is just wild to think about.
Right. I mean, the era of the cute little AI chat box, the experimental pilots and tech demos that look like magic but don't actually run anything, that era is dead. We are now officially in the agentic era.
Yeah, and what that means is we've moved from humans prompting models to autonomous agents, executing complex multi-step workflows entirely on our behalf.
It's a massive shift.
It really is. It's a structural shift in how computing fundamentally operates.
So we are dedicating this entire deep dive to unpacking exactly how that shift happened. We're looking strictly at Google's AI updates published between April 26th and May 2nd, 2026.
Right, just that 1 week.
Exactly. And what you're going to see is a comprehensive map of a company fundamentally re-engineering its entire stack. I mean, from the basic math of healthcare all the way up to classified military networks and the raw silicon sitting in data centers.
Because, to understand how a technology generates $20 billion, you really have to look at the underlying research first.
The foundation.
Exactly. The foundation dictates what the commercial product can actually, do in the real world.
Well, let's look at the medical field then. On April 30th, Google DeepMind launched an AI Co-Clinician research initiative.
Right.
They built this system to augment primary care, and they evaluated it head-to-head against human physicians. And in 98 primary care queries, the system achieved 0 critical errors in 97 of them.
That's a huge metric.
It is. And when compared to leading evidence synthesis tools, human doctors actually preferred the AI.
Yeah.
But I have to ask, doesn't AI actually outperform a human doctor across the board, or is it just acting as a highly efficient search engine for medical records?
Oh, it is much more than a search engine. I mean, think about the cognitive load on a human primary care physician.
It's massive.
Right. They are reviewing mountains of patient history, cross-referencing intersecting symptoms, and trying to recall the latest peer-reviewed medical literature all at once.
Which is impossible for one person to hold in their head.
Exactly. Human doctors are prone to fatigue. Cognitive bias creeps in. But what the co-clinician does is synthesize evidence without that friction.
So it's not replacing the doctor?
No, not at all. It's not replacing the physician's diagnostic judgment. It is perfectly synthesizing the available evidence so the human can make a vastly more informed decision.
Oh, wow.
Yeah, the AI matches the human in diagnostic safety, but vastly outperforms us in the sheer volume and speed of connecting those medical dots.
That transition from just retrieving data to synthesizing it perfectly, that bridges right into what Google Research published regarding public health, right?
Yes, on April 29th.
Right. They took their empirical research assistance system, known as ERA, and moved it out of retrospective validation into real-time prospective application for public health epidemiology.
Which is a major leap for the global medical community, though, the current data focus is mostly in the U.S. right now.
Okay, so what does it actually do?
Well, ERA automates the generation of expert-level empirical software. Previously, they tested it by looking at past outbreaks to see if the AI would have caught them.
Like a retroactive test.
Right. But now it is actively predicting the future.
It's submitting weekly infectious disease forecasts, and it currently ranks #1 on the CDC public leaderboards for both flu and COVID-19.
Yeah, and the mechanism here is what really matters. When an AI system moves from reactive data collection to, predictive forecasting, public health officials can completely change their strategy.
How so?
Instead of reacting to a sudden surge in hospital admissions, they can allocate vaccines and staff to a specific zip code weeks before the outbreak even peaks.
Just based on the model's predictive software generation.
Exactly.
Wow. We're talking about mapping incredibly complex human factors, which brings us to Earth AI. On April 28th, they detailed a new family of geospatial AI models powered by a Gemini reasoning engine.
Right. This is fascinating stuff.
It really is. They're jointly analyzing satellite imagery, air quality, and search trends. And they're distilling anonymized population dynamics into 330-dimensional vectors.
330 dimensions.
Yeah. I mean, how does that math even work in a way that applies to the real world?
Well, the human brain really struggles to picture anything beyond 3 dimensions, right? Length, width, and depth.
Right, obviously.
But in machine learning, a dimension is just an axis of meaning. Imagine an incredibly vast mathematical space. Axis 4 might represent humidity.
Okay.
Axis 5 could be the density of broadleaf trees from satellite data. Axis 6 might be the volume of Google searches for cough medicine in a specific county.
So the AI is plotting a single dot that represents all 330 of those variables at once.
Yes, exactly. And in that mathematical space, distance equals correlation.
Oh, I see.
So the AI can mathematically see that a slight change in satellite vegetation data, combined with a local pollen spike and specific air quality metrics, sits right next to a spike in respiratory illness.
That's incredible.
It maps environmental and human factors into a shared mathematical language. It identifies hyper-local risks that human epidemiologists might just never connect.
But, an AI that understands 330 dimensions of planetary data is pretty useless if developers can't easily plug it into an app.
Absolutely. The models have to hit the real world.
So let's look at how developers are actually building with this. On April 30th, Google Cloud released the general availability of Gemini Embedding 2.
And this is perhaps the most critical piece of infrastructure for the agentic era.
Really? Why is that?
Because it's the first embedding model in the Gemini API capable of mapping text, images, video, audio, and documents into a single unified embedding space.
Wait, so if I'm a developer building an app, I don't have to build a translation layer between my video files and my text documents anymore. They literally speak the same mathematical language.
That is the breakthrough right there. Historically, developers had to use one model to process video and a completely separate model to process text.
Which sounds like a nightmare.
It was.
Oh.
If a user wanted to search a video database using a text query, the developer had to build this clunky, inefficient bridge between those two silos.
Right.
But Gemini Embedding 2 takes up to 120 seconds of video, an 8,192 token text document, and a 6-page PDF, and drops them onto the exact same map, a 3,072 dimension space.
So the text phrase, a dog catching a frisbee, and the actual raw MP4 video of a dog catching a frisbee have the exact same mathematical coordinates in this space.
They do.
That is wild.
And the API allows developers to truncate those dimensions to save memory while preserving the core meaning. A developer can now process all those different data types in a single API call.
Wow.
AI agents no longer have to translate between mediums. They just retrieve the meaning natively.
And Google is removing friction on the coding side, too. On April 29th, they announced the open sourcing of a Colab MCP server, and MCP stands for Model Context Protocol.
Right, and this changes the fundamental workflow of writing software. This server allows any compatible coding agent, whether that's Cursor or the Gemini CLI, to directly drive Google Colab notebooks.
So if an agent is trying to analyze a data set, the developer doesn't have to, ask the AI for the Python code, copy it, paste it into their notebook, and run it to see if it works.
No, the copying pasting is completely gone. Colab is now a programmable agent-native compute backend.
Oh, wow.
The AI agent actually pilots the notebook. It adds the cells, writes the code, executes the analysis, reads its own errors, and generates the visualizations completely autonomously.
So the developer acts as the supervisor, not the typist.
Precisely.
We're seeing that same shift from assistant to producer for everyday consumers, too. The April Gemini drop introduced native file generation within the Gemini app on April 30th.
Which is great.
Yeah, users can generate fully formatted, downloadable PDFs, docs, sheets, and CSVs directly inside the chat interface.
You know, it sounds like a small feature, but it closes a massive productivity gap.
How so?
Well, asking an AI to generate a table of data, only to have to manually copy, paste, and format it in Excel, that breaks the workflow. Handing the user a finished, ready-to-use file turns the AI into a direct production tool.
And their production capability is moving into the living room, too. On April 29th, generative AI launched on Google TV in the U.S.
Right, the Create workflow.
Yeah, powered by Nano Banana 2 and VO 3.1. Users can generate and edit images or short videos directly on their televisions using just voice commands.
Moving generative media from the private screen of a smartphone to the shared social screen of a television is a significant cultural shift.
For sure.
But technologically, it really reveals the hardware demands of edge computing. This feature is initially rolling out only to Gemini-enabled TCL TVs that have at least 2 gigabytes of RAM.
Because running models like Nano Banana 2 locally requires actual hardware muscle.
Exactly. You cannot send every single voice command to the cloud and wait for a generated video to stream back without terrible latency. The TV itself has to handle some of the reasoning.
But, depending on where you live, that AI access is highly asymmetrical. On April 30th, Google permanently shut down the Whisk experimental image remix tool.
Right.
They folded the remaining users and AI credits into the unified Flow creative platform. But unmigrated media was permanently deleted. And crucially, Flow lacks a migration path for users in unsupported regions like parts of the European Economic Area.
Yeah.
If you were in the EEA, you just lost your tool and your data.
It really highlights the fracturing of the global AI landscape. Regulatory environments and the sheer cost of infrastructure mean that the agentic era is not arriving everywhere all at once.
Speaking of infrastructure, running an AI that builds TV graphics on the fly while simultaneously writing its own Python code requires an absurd amount of raw compute.
Oh, absolutely.
So let's talk about the physical silicon powering this. On April 28th, Google announced the 8th generation TPUs, the TPU-8T and the 8i.
Right, and Google custom engineers these tensor processing units specifically for the math required by neural networks.
Okay, so what's the difference between the two?
Well, the 8T is the heavy lifter. It's built for training massive frontier models, scaling up to 9,600 units in a single superpod. It delivers a 3x processing boost over the previous generation.
Wow. But the 8i is what really caught my eye because it's built for inference-like, the actual running of the agents.
Yes.
The engineering challenge here is fascinating. An agent is constantly reasoning, retrieving data, and looping back on itself. In older chip architectures, the processor would often just sit idle, waiting for data to travel from memory.
Exactly.
It's like a brilliant chef stuck in a kitchen where they have to walk out to the grocery store for every single ingredient. The processor is just starving for data.
That is the waiting room problem. Memory bandwidth simply couldn't keep up with the processing speed.
Right.
But the 8i fundamentally re-architects that relationship. It eliminates those memory waiting rooms by keeping more data on chip, basically putting the entire pantry directly on the chef's counter.
That's a great way to put it.
The travel time is gone, which delivers 80% better performance per dollar when running these autonomous agents.
And they are attacking the data travel problem on the software side, too. On April 29th, they detailed a new feature called Rapid Bucket for PyTorch.
And PyTorch is one of the premier AI frameworks globally.
Right. Google integrated their internal Colossus storage architecture directly into the PyTorch ecosystem using bidirectional gRPC streams.
Which is a huge deal. Loading massive data sets to train a model usually involves sending data in slow, individual packets across a network. It creates a massive bottleneck.
Right, it takes forever.
Exactly. But a bidirectional gRPC stream essentially replaces that drip feed with a massive, high-speed, two-way pipeline.
So by connecting PyTorch directly to Colossus, which is the same storage behemoth that powers YouTube and Google search, researchers are loading data sets up to 5 times faster.
5 times?
Yeah, it resulted in a 23% reduction in total training time during benchmarks.
And when a company is renting thousands of AI chips by the hour, cutting training time by nearly a quarter translates to millions of dollars saved. It changes the economics of AI development completely.
But you still have to put these chips somewhere. On April 27th, Google broke ground on the Visakhapatnam AI Hub in India.
Right.
Partnered with the Dana Connects and Airtel, this is a gigawatt-scale AI data center campus and subsea cable landing station.
The physical constraints of this era are just staggering. I mean, a gigawatt is roughly the output of a large nuclear power plant.
Wow.
Yeah, this is Google's largest investment in India's digital infrastructure, and it is entirely necessary to support the global compute load these agents require.
So you have these gigawatt data centers powering highly autonomous agents capable of writing code and synthesizing global health data. Who is actually allowed to use them and how are they governed?
That's the big question.
It is. On April 28th, it was reported that Google signed a classified AI deal with the U.S. Department of Defense.
Right. And the agreement permits Google's Gemini models to be deployed on classified military networks.
Okay.
It allows for any lawful government purpose, though it explicitly excludes the use of the models for autonomous weapons without human oversight.
Now, obviously, we're not taking a political stance here on this deep dive. We're just looking at the facts.
Mm-hmm.
And the operational reality is that the government requires secure, state-of-the-art technology to synthesize intelligence and maintain national security.
Absolutely.
However, the deployment of generalized AI in a military context triggered immediate internal pushback. Over 600 Google employees actually signed a protest letter condemning the deal.
Yeah, it really highlights the deep tension within the industry regarding the control and application of these systems once they reach production scale.
And the question of control extends far beyond military contracts. It reaches directly into personal finance. On April 28th, Google Payments contributed its Agent Payments Protocol, or AP2, to the FIDO Alliance,
Right.
and they simultaneously released AP2 version 0.2 on GitHub. Now, the FIDO Alliance handles the global standards for authentication, like how your Face ID or fingerprint unlocks your banking app.
Right. Verifying the human.
Exactly. The entire philosophy of FIDO is
Mhm.
verifying that the human is present. But AP2 introduces human not present payment flows.
Yes, it does.
Wait, handing my credit card to a bot while I'm asleep. That sounds like a fast track to bankrupting myself on concert tickets I didn't even want.
I know, it sounds dangerous, but the encryption mechanism is designed to prevent exactly that.
How does it work?
Say you authorize an agent to buy limited run tickets the millisecond they go on sale at 30 a.m. AP2 creates a cryptographic token of your specific intent.
Okay.
It establishes a multi-vendor standard so the ticketing website can securely verify that this specific autonomous agent is authorized by your verified identity to execute this exact limited run purchase.
Oh, I see.
The vendor knows it's your bot without you actively clicking buy.
But secure systems where agents act on our behalf, we have to know the AI itself hasn't been compromised. So on May 1st, Google announced a binary transparency ledger for Android applications.
And this is a defense against supply chain attacks. A hacker might try to sneak a malicious, hijacked version of an AI module onto your phone through a routine software update, specifically to intercept the data your local agent is processing.
Right. But the transparency ledger acts as a cryptographically secure, append-only public receipt.
Exactly.
Before your phone runs any on-device AI software, it checks the ledger. If the exact digital signature of that software isn't on the authorized Google receipt, the phone refuses to execute it. It guarantees you are running the genuine model.
When you pull all these threads together, the physical infrastructure in India, the advanced silicon, the military applications, and the payment protocols, you see why the financial gravity of the tech sector has fundamentally shifted.
The numbers definitely back it up. Alphabet CEO Sundar Pichai revealed the Q1 2026 earnings on April 29th. The adoption of this vertically integrated AI stack is just staggering. Google Cloud crossed the $20 billion quarterly revenue threshold for the very first time.
They reported an 800% surge in generative AI product adoption.
800%.
Yes. And the most vital metric is their cloud backlog, which represents future contracted revenue. That backlog pushed to over $460 billion.
That is insane.
Enterprise demand has fully transitioned from testing small concepts to signing massive multi-year contracts for agentic infrastructure.
And we are seeing that enterprise infrastructure reach consumers in unexpected places.
Yeah.
On April 27th, General Motors announced they are replacing Google Assistant with Gemini across roughly 4 million eligible vehicles with Google built in.
Right. And moving from a generic assistant to Gemini provides a highly conversational co-pilot. But the technical differentiator is that the system is fine-tuned on the proprietary engineering and vehicle manuals for the specific car.
So it's grounding the AI in the physical reality of the chassis.
Exactly.
Instead of just asking for directions to a coffee shop, a driver can ask, Gemini, what does that weird blinking orange light on my dashboard mean?
Right.
And the AI reads the diagnostic codes and cross-references the actual manual for that exact make and model to provide the answer.
It's incredibly useful, and this global integration is accelerating scientific infrastructure as well. To close out the week, Google DeepMind signed a landmark memorandum of understanding with the government of the Republic of Korea on April 27th.
Right. They are establishing the first ever Google AI campus in Seoul.
It cements South Korea as a pivotal hub for AI-led scientific discovery. The partnership focuses on leveraging models like AlphaFold directly within academia and the life sciences, basically sharing compute resources and expertise at a national governmental level.
Just look at the sheer velocity of the developments published in just these 7 days.
It's dizzying.
It really is. We moved from the theoretical math of 330-dimensional planetary modeling to the deployment of 8th-generation silicon designed specifically to run it without memory bottlenecks. We saw the technology adopted by the Pentagon, integrated into 4 million vehicle dashboards, and granted the cryptographic ability to spend our money while we sleep.
The through line is undeniable, though. AI is no longer a tool you simply query. It has become an active, agentic layer of the internet, operating autonomously in the background of society.
It's out of the test track and dominating the highway. Which leaves us with a profound question regarding how we adapt. We just explored a protocol where AI agents can execute purchases without a human present.
Right, the AP2.
Exactly. But if an autonomous agent glitches, say it misinterprets an instruction, and buys 10,000 non-refundable concert tickets using your cryptographically verified identity, who is legally liable?
That's a scary thought.
Is it the bank that processed it? Google who built the agent? The vendor who accepted the AP2 token? Or you? As we step fully into the agentic era, we all need to start thinking very carefully about what digital identity actually means when your AI holds your wallet.